All right, everybody. So here's where we get into the real good stuff. Lesson 4, factoring polynomials in the form ax squared plus bx plus c, where a equals 1. Don't freak out if that looks confusing. Basically, it means we're factoring trinomials where the coefficient of the x squared term is just 1, the easy version, where it's x squared plus something x plus some constant, okay? Let's start here. Polynomial, sketch of the rectangle, grid, and factors. What I'm going to be doing is showing you the same trinomial 4 different ways. So in this version, we've gotten the algebra tile sketch. So let's start by making sure we know what polynomial this is. So this thing's got an x squared tile, one x squared tile. So just like I said, there's only a coefficient of 1 on the x squared. That's what we're really dealing with here is one x squared tile in all of these. Then there are 3 x tiles, so plus 3x, and 2 individual tiles, so plus 2. So that's just a little review of algebra tiles there. Okay, well, we could also write this in a grid form. Now, in the grid form, it looks exactly the same as the algebra tiles. There's the x squared in the exact same spot as the x squared tile would be. There's the positive 2x in the exact spot that the 2x were right here. Then we have down here a singular x. And finally, in this bottom corner, we have the plus 2. Okay, so take a look. Look at the columns and the rows individually. Let's start with this column, x squared plus x. Well, if we look, the GCF of x squared and x is x. Now, if we look at this column right here, 2x and 2, the GCF of that, we're going to include a sign with this, is positive 2, right? They both have a 2 in common. Now let's look at the rows. This row, x squared and 2x, well, that has an x in common between the two of them. And this row, right here, between x and 2, well, there's really nothing in common. And like we've always seen in the past, if there's no greatest common factor, then they have a greatest common factor of 1, right? We can always divide something by 1. So then what we get are these 2 binomials. So our factors, our polynomial, can be written as x plus 2 times x plus 1. And in fact, you can see it with the algebra tiles too. This would be x plus 2, right, along the top, and this would be x plus 1 along the bottom. They would multiply out to those tiles. So this and this are the same thing. This is factored form. This is expanded form. But they have the exact same value. If you were to multiply this factored form one out using binomial multiplication, you'd get this. Okay, well, let's try another one. Here, we're given the grid. So now what we're going to do is we're going to multiply using our usual multiplication method. So x times x in this little grid space right here is going to be x squared. Then I'll do x times 4. So in this grid, we're going to get 4x, specifically positive 4x. Now let's multiply the negative 1. So negative 1 times x is going to be negative x, and negative 1 times 4 is going to be minus 4. Okay? So let's translate this whole grid into our algebra tiles. We have one x squared tile in the top corner here. So that's our x squared tile. Then we have a negative x tile right next to it. So that's the skinny one not colored in. Then we have 4 x tiles. So those are positive x tiles, so I'm going to have to color those ones in. And finally, we have minus 4 little guys in the corner here. Like that. So we can see that our polynomial is we have, well, one x squared tile. We have 4 x tiles and 1 negative x tile. So those come together to make 3x. And we have 4 little negative ones, so minus 4. We could have accomplished that with the grid as well. We have x squared, minus 4, and these two we add together, because they're common, to get 3x. And then finally, that gives us our factored form. Well, our factored form is pretty easy. It's these. So that's going to be x minus 1 times x plus 4. Remember, this is, if it doesn't have one there, it's automatically positive if there's no sign listed. We're adding the things together. Okay, so now we're moving on to 2, where we're given the polynomial to begin with. So what I'm actually going to start with is I'm going to start with the algebra tiles. Now, this takes a little practice, so for now you're just going to trust me. Just trust me, okay? I'm going to start with the grid. Sorry, did I say algebra tiles? I did mean grid. I'm going to start with the grid. So I'm going to put the x squared tile here, and I'm going to put the plus 3 here. Okay, because I know those go in those corners. They always do. The tricky part now is this guy, the middle tile. What I need to do is I need to break those up so that when they add up, they'll add up to 4x. But I also need to make sure that they're going to give me something that multiplies to this guy right here. So, what can we use? Well, if I draw this with algebra tiles, that might help. Here's my x squared. Here are my 3 little 1 tiles. Now let's see what we get. Well, if I just follow the pattern, these are going to have to be x tiles, right? And in fact, they're going to have to be positive x tiles. And this is also going to be an x tile. So that's a total of 4 x's, just like I wanted, where I have an x here and a 3x here. So I can do my factoring. I get x factor 3x and 3, you get positive 3. Factor x squared and 3x, we get x. And finally, factor x and positive 3. Well, nothing else in common there. We get 1. So this is going to be x plus 3 and x plus 1. Last one, x squared plus 5x plus 6. So I got x squared in this corner. I've got the 6 in this corner, but I need 2 things. They're going to add up to 5x. But they can't just be anything. They still have to work in my grid. So there's my setup there. I'm going to arrange mine like this. Now, I'll be real with you. At this particular point, doing it like this is a little bit of trial and error. What works? I will be showing you a more surefire way of doing this very soon. So don't worry if you don't know how I figured out which one was the right one. I'll be getting into that in just a minute. All right, so what I can do is I can say, okay, well, that's going to be 2 tiles here so that it fits, and 3 tiles here. As long as you can form a perfect rectangle with your algebra tiles, it works. So there was other way we could have arranged it. We could have arranged it with 3 tiles here, and 2 tiles here, and we would have gotten the same outcome. Same thing, just turned. So what I see here is that I've got 2x up here, and I've got 3x down here. So I do my factoring. These two, these two, these two, and these two. And I get in the green column, x is common, In the pink column, 2 is common. In the orange row, an x is common. And in the blue row, a 3 is common. So that makes that my factors are x plus 2 and x plus 3. And again, if we want to know we did it correctly, we can always check our work. X times x is x squared. X times 3 is plus 3x. 2 times x is 2x. And 2 times 3 is 6. Combine our like terms, and we get x squared plus 5x plus 6, which is what we wanted from the beginning. All right, so that's sort of the visualization of what factoring a trinomial like this really is, and why it works, and how they're the same thing. Let's look at a slightly more algebraic method, a method that doesn't require you to draw anything. That grid method, by the way, always going to work. But let's be a little bit more clear. So factoring trinomials of the form ax squared plus bx plus c, specifically when a equals 1, here's the steps. Step 1, set up a pair of brackets. Each with an x. So this is for our inspection method. Something you're going to be able to do and just look at it and factor it in your head in like a second. So we start with that. We're going to say, okay, this is bracket, 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 x, x. So that's our step 1. Step 2, find a pair of numbers that multiply to c and add to b. So just to be clear, by b I mean the coefficient of x, and by c I mean the constant. Okay, so in this case, that's our constant, -10, and our coefficient of x is +3. So we're looking for something that multiplies to -10, product of -10, but a sum, s, of +3. So what I recommend is we should just go through the factors of -10. So -10, what are the factors? Well, -1 and 10, 1 and -10, 2 and -5, 2 and 5. Those are all the factors of -10. So we look through the list and see what they add up to. Well, -1 and 10 is 9. 1 and -10 is -9. 2 and -5 is -3. And -2 and 5 is +3. Hey, use a different color. Don't want to confuse. No, actually, that's perfect. This one adds up to our sum of 3 that we were looking for. So that brings us to step 3, the final step. Put these numbers in the brackets. 1 in each. So make sure you keep the signs with them. For our final step, we're going to do x minus 2, x plus 5. So you can see we've got the 2 numbers that we chose are put in there, 1 in each. And the order doesn't really matter. As I said, you could do x plus 5 times x minus 2. It's the same. It doesn't make a difference. And that's how you factor by inspection. Now, once you get good at this, you'll start being able to do this all in your head, and you'll be doing it really fast. But for now, that's how you get it done. All right, let's look at a couple examples. First, we have x squared plus 10x plus 24. So what I need to identify is my b and my c. So there's my b. There's my c. I need to find a product of 24 and a sum of 10. So we list some of the things that multiply to 24, positive 24 in this case. So I'm going to say, okay, well, 8 times 3 works, and 6 times 4 works. And, oh, hey, 6 times 4. That adds up to 10. 8 and 3 doesn't. That adds up to 11. So I found the one that works. So bracket, 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 x in each. I'm going to put a plus 6 in one, a plus 4 in the other. And if we were to check our work, that says cheek our work. If we were to check our work, which you should always do if you're uncertain, even if you are certain, it doesn't hurt to check. X times x is x squared. X times 4 is 4x. 6 times x is 6x, and 6 times 4 is 24. Combine our like terms, x squared plus 10x plus 24, which is exactly what we started with, so we know we did it correctly. All right, let's look at B. F squared minus 8f plus 12. So, bracket, 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 x, x. Okay, now our product, we've got a constant of 12, and our coefficient of the x, or in this case f term, is negative 8. So we have a product of 12 and a sum of negative 8. So if I have a product that is positive and a sum that is negative, well, the only way to get a positive product is if both numbers are positive or both numbers are negative. And if the sum is negative, that means both numbers have to be negative. So let's look at some products, things that give a product of 12. Well, negative 3 and negative 4 would give 12, but that doesn't add up to negative 8. How about negative 6 and negative 2? Hey, that adds up to negative 8. Beautiful. So those are going to be our options. And as always, you should check your work. I'm not going to do it every time, but another way we can check our work is with our grid. So in our grid, we've got f squared, we've got 12, we've got our two factors that we are trying to test out here, which is x minus 6 and x minus 2. Let's see if they work. And by x, I definitely have meant f this entire time. Whoops-a-daisies. My bad. I get so caught up with the f's. So, what I need to check here is that my f's all work out. So f, well, if there's an f squared here, this needs to be an f common here, but there also is a negative 2. F times negative 2 is negative 2f. Negative 6 times f is negative 6f. And if I combine these two, that gives me negative 8f. So it all works out. We get our polynomial of f squared minus 8f plus 12. Cha-ching. All right, n squared minus 11n minus 26. Looking for a product of negative 26 and a sum of negative 11. So I'm looking for a negative product, which means one has to be positive, one has to be negative. So in this case, you can start to see them a little bit faster. If you try a negative 13 and 2, you'll find that that one gives you negative 11 and multiplies to negative 26. So that's our golden boy. Be careful, because if we did 13 and negative 2, that does not add up to negative 11. That adds up to positive 11. So that one's wrong. This one's right. So I do bracket, 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 bracket. Don't forget to use the right variable this time, Sam. N and n, negative 13, positive 2. And of course, use expansion to check your work. And last one here. All right, well, this one is interesting because I didn't teach you what to do if the coefficient is 5. Unless there's something we've done in a previous lesson. 5x squared, 35x, and 60. They all have something in common. They all have a 5. So if I take out the 5, that leaves me with x squared minus 7x plus 12, which I can then factor by inspection. Now I'm looking at a product of 12 and a sum of negative 7. That's not the right color. A sum of negative 7. So our product is 12, and our sum is negative 7. Again, the sum is negative, and the product is positive, so both numbers have to be negative. So let's try, woo, that was exciting. Let's try negative 3 and negative 4. Well, that wouldn't. So that gives us negative 7. So we leave the 5 out front, bracket, 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 because we still need to ultimately multiply this thing by 5 for it to work, right? At the very end, we're going to multiply by 5. Then we get x minus 3 minus 4. And every step should work backwards. So when I expand these two polynomials out, I should get to this step. When I multiply by 5, I should get back to this step. That's how you know you're doing it right. All right, that brings us to this point. Sometimes you have to factor out a GCF. Sometimes there's a GCF. So in this first one, the GCF, 3x squared, 12x, and 36, the GCF is 3. So I pull that out, I'm left with x squared minus 4x minus 12. Then I do bracket, 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 x, still left that 3 out there. That doesn't go anywhere. I am now, though, looking for a product of negative 12, and a sum of negative 4. So if I think about that one, I need it to be one negative, one positive to get a negative product. So I'm going to use negative 6 and positive 2. That gives me a sum of negative 4. So minus 6 plus 2. And again, multiply the whole thing out to check your work. F, y squared, y 20. Hey, there's nothing common here. Sometimes there's no common factor to do first. You should always check, though. Is it there in this case? No. So we can jump straight to a product of negative 24 and a sum of negative 2. When we work that one out, we get negative 6 and 4 will give us a sum of negative 2 and a product of negative 24. Bracket, 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 y, and we have y minus 6 and y plus 4. I don't know why we're suddenly at question M, but we're at question M now. Now I look through, are there any common factors? Well, yeah, there's an m common in this one. So I'm left with m squared minus 9m minus 10, which is a lot nicer because that looks like the form we're used to. We haven't done m to the 3 or whatever for our factoring. Come on. So I'm looking for a product of negative 9 and not a product of negative 9, a product of negative 10. There we go, and a sum of negative 9. So if I work through that, I have negative 10 and positive 1. That will give me a sum of negative 9 and a product of negative 10. M, bracket, 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 m, m. And then I have minus 10 and positive 1. And finally, n. I have these 3 terms, and if we look, there's some stuff common here, most notably a y. So I pull out the y, and we're left with x squared minus 4xy plus 4y squared. Now this might look like we haven't done anything like this before, but here's the thing, there's a beautiful symmetry here. X squared with 1x, y squared with 1y. We can actually treat this exactly the same way we have done other ones in the past. Oops. That is going to be our c value. We can just kind of ignore the variable there. And that is going to be our b value. If we have this nice symmetrical one where it's variable squared minus a constant times variable times that other variable plus number times the other variable squared, and it looks nice and symmetrical like this, No change to our process at all. Now we're looking for a product of positive 4 and a sum of negative 4. Well, product of positive 4, we know both numbers have to be the same sign. In this case, they both have to be negative 2. That gives us a sum of negative 4, but a product of positive 4. So this time the only difference is bracket, 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 bracket. Not only do I need to put an x in place, I also need to put a y in place so that I get a y times y gives me that y squared. So I'm going to put, I'm just going to make myself a little more room here. Y. So this is going to be minus 2y minus 2y. And if you're not convinced, let's do a quick check to finish this off. So we're going to do our y times our x minus 2y times our x minus 2y. We do our multiplication. First, I'm going to do the binomials. X times x is x squared. X times negative 2y is minus 2xy. Negative 2y times x is minus 2xy. Negative 2y times negative 2y is positive 4y squared. Combine my like terms. X squared minus 4xy plus 4y squared. This should already start looking familiar. Finally, multiply the y to everything. X squared y minus 4xy squared plus 4y cubed. Cha-ching! And that is everything. All right, the next page is practice. Please practice. Otherwise, have a good one, folks.